So now this next loop, it's called a do while loop. This is not required for your test, but it's good information to have. All right. It's the same thing as a while loop, only you execute the statement first and then evaluate the test condition. So you do all the statements here while this expression is true. The biggest difference between the two is that it's guaranteed to be entered at least one time, the very first time. So this is a do while here. This is an old piece of code that I used. So we're going to assume we're using scanner instead of console here. And we'll say in dot next int. Okay, so this is, again, we have int number and total. They both equal 0. So they're both 0. So it says do this. And so it does this first. So first it prints out enter an integer, and then they'll print out, like maybe they'll enter 6. If it's greater than or equal to 1, or sorry, greater than or equal to 0, I'm going to add it to total. So this is 6. And now it says while. So now I evaluate this truth statement to see whether I can keep going. So is 6 greater than 0? Yes. So I'm going to go in again, system.out.print, enter an integer or -1 to quit. So maybe they enter 7. And then number becomes in.nextInt, which is 7. Oh, that's correct. So then they enter 7. If number is greater than 0, total plus equals number. And so then this will be 13. And while it's going to go in again, number is greater than or equal to 0 because 7 is greater than or equal to 0. Enter an integer. Maybe this time they enter -1. And so here's this if statement here. If number is greater than or equal to 0, which it is not right now, so because it's not the case, it's not going to add to total because it doesn't do this. And then while number is greater than or equal to 0, it's going to stop here. The end value for total is 13. The end value for number is -1. Now, do while loops, they also have initialization, testing, and increment. Okay. The initialization is done here with number becomes 0. Okay. The testing is actually done down here at the bottom. And then the increment, in this case, the increment is like entering a new number each time because that's what makes it that's what makes this quit. Okay. So when do you want to use a do while? Well, if you want to go in at least through one pass, then you want to use a do while. If you don't want to have one pass, then you can just use a while. So if you want to force it to go in once, you can use a do while. Okay. Let's write a method that will take an integer n as a parameter and use a do while loop to calculate and return n factorial. So maybe I will say, I'm going to do this over here just because this is it's already open. I'm using it as our testing. So I will say, it doesn't really make sense in our student class, but we're just going to use this for testing cases so that you can see. So it's a method. I will say public, maybe void. I'll call this factorial. And it takes in an integer n. Okay, so maybe I'll start out with something that's called factorial. And it will hold 1 at first. And then I'm thinking about this as I'm going, so I might have to edit a little bit. Then I'll take in just a number, so and I'll say, well, actually I don't need to do that. Maybe I'll just say do. Oh, and so while, let's see, I'm gonna say factorial. times equals 1. I'm sorry, times equals n, and then n minus minus. But I want to make sure first that if n is greater than 0, because I don't want to do this if it's less than 0, because it won't. Or if it's 0, it'll make everything equal to 0. It'll make factorial equal to 0. And also, if it's less than 0, it's going to make it negative. So that's my if statement there to kind of take care of that. And then I want to subtract. So if I start with 6, I want it to go down to 5, and then 4, and then 3, and then 2, and then 1. And then, let's see, while it's going to do this, while n is greater than 0. Because once n becomes less than 0, it'll stop. And then I'm going to return. Oh, need a semicolon there. Not used to that, because in the while loops we don't put a semicolon. Return factorial. So let's see if this works. Oh, let's make this an int. Actually, we'll make a void and we'll just print. System.out.println. I'll say n factorial. Whoops, because in math we use it with a exclamation point equals my variable factorial. All right, so over here, I am going to comment out test average and Billy. Maybe I'll make this thing static too. Public static void. So then I can just call it on the class because I'm just testing here. So I will just say student dot factorial. There we go. And we'll do 3 because 3 should be 3 times 2 times 1, which is 6. So I made it static because, excuse me, it's not dependent on any student. Not that I would have this method in this class anyway. But notice that because I made it static right here, I had to call it on the class. So let's run it and see how I did. And there we go. Oh, it says 0 factorial. My bad. Because this became 0 and popped out of the method, but I didn't want that. So let's go back in here. My answer is correct. But maybe I'll just say up here, number becomes... Oh, maybe I'll just say... Yeah, because it got changed inside the method. Int number becomes n. And then I'll say number down here. Or I could, I think this is, I could just do a system.out.print. I don't want to print right in the middle of my method, so I'll just say number. That's holding my original value. And now if I run it, it should say 3 factorial equals 6, which is correct. So now we've gone through the while. I did want to show, this is something I ran into. So while loops, I want you to pay attention. While loops do not have a semicolon here, okay? But do while loops do have a semicolon after their expression. They don't have a semicolon after their do. So that's just something to be aware of. Now we're going to talk about the for loop. I like to use for loops more than while loops. While loops are really good if I don't know how many times I'm going to go through something. A for loop is, or if you're basing something on user input. A for loop is really great if you already know how many times you're going to go through. And the reason why I like it is because your initialization, your testing, and your incrementation are happening all in one like line of code. So if something is wrong, you can look at that one line of code and see, all right, everything's kind of dialed in right there. I can see exactly what's going on there. So statement 1 initializes the variable. Statement 2 is the testing. It's a Boolean expression. And statement 3 increments it so that it will eventually become false and you can pop out of the loop. Okay. This loop here prints out the numbers between 1 and 10. The number I starts out as 1. Okay. This happens one time at the very beginning. So it prints out 1 and then you increment. So then you go to this part of the code, I++. So then it becomes 2. And then I test. Is 2, actually, first I say I is equal to 1. Then I say, is 1 less than or equal to 10? Yes. Then I print. Then I increment. So now I'm at 2. Now I go back here. Is 2 less than or equal to 10? Yes. Then I do what's in the loop, which is print. And then I increment. So then I go 3 and so on. 3, test, increment. 4, test, increment. All the way until I get to 10. Okay, so I print out, is 10 less than or equal to 10? Yes. Okay, then it's going to increment to 11. So I printed. Then it equals to 11. And then it says 11 less than or equal to 10? No. So now I exit the loop and go to whatever else is out here. Okay. Like I just said, initialization, this happens one time. This happens before each pass, and this happens at the end of each pass of the loop. So this happens before you go inside the statement. This happens after whatever the statement has occurred. I like to use a for loop when I know the number of iterations. So like I know the number of things I'm going to go through in advance. So let's do the same method. So I will leave this down here. And I'll leave my int factorial. So I'll just take out my do while. And I'll say for int I, I'm going to say becomes n. And actually here I can take this out because my loop is not going to be based on n. I'll show you in a minute. N is going to stay the same. Okay, well, n is greater than 0. N minus minus. Or sorry, I minus minus. So generally, in a for loop, if I have some sort of like case here, like the number that I'm going to put in here, my parameter, I'm going to withhold using my parameter. I'll use something like I. I is usually for index or X or times or rows. R for rows, C for columns. And then I will set that equal to n. So you can see I'm not increasing or decreasing n here. So when I print out n, I'm still going to get the value that I put in here to begin with. I based it all off of I, so I'm pretty safe. And then I'll say factorial times equals I, which is really nice. You can see how much this just shortened my code out. So we'll see how we did. All right, now let's give it a run. So it says 3 factorial becomes 6 or equals 6, sorry. So yes, we've successfully done it. You can see it used a lot less code. Any sort of mistake is going to be, any sort of mistake within the loop boundaries or with the loop stuff is going to be all here in this one line, which is why I like it. So that's use of a for loop. Now, I also have nested loops. Okay, a nested loop is when we put a loop inside another loop. Generally, we do that a lot with for loops. We might do them with while loops as well. And so, like, what we're going to say, like, what is this loop doing, okay? Because I have a for loop here and a for loop here. You see I have a row and col, so I'll assume that there are rows and columns. So I have row, it looks like a row is 1, it's going to 4. It looks like a column is 1, it's going to 8. So I would, and then I'm printing out stars, and then I'll have a print line. So usually I'm going to say have something like row here and call here. So row is 1 and call is 1. So this is how I like to keep track. And so call is 1 and I print a star. And now call plus plus. So call is 2 and I print another star. 3 and I print another star. 4 and I print another star. 5 and I print another star. 6, I print another star. 7, print another star. 8, it's less than or equal to 8. I'm going to print another star. Okay. And now, is 8 less than or equal to 8? No. So now I'm going to go to the next one. Now row is going to become 2. Is 2 less than or equal to 4? Yes. So then you can assume you're going to print, it's going to do the same thing, another 8 stars. And then this becomes 3. And then it prints another 8 stars, just like it did before. And disregard my messy stars. Now we're on row 4. 4 is less than or equal to 8. Now remember, this whole thing is going through column each time. I could rewrite it, but because there's no real big changes here, it's going to just do the same exact thing. So now 4 is less than or equal to 4. Yes, so I'm going to go inside here. And now 4 becomes 5. So is 5 less than or equal to 5? No, I'm going to skip and go on. Now, I wanted to make 2 cases here. You see, this is a print, so that's why I stayed all along the same line. And then once I hit 9 here, so once this thing became 9, I went to print line, the next line. Now, you can see that this is sort of like an if statement here. The first line of code for a for loop, if there are no curly braces, is the only one that directly applies to the loop. Okay? If there are curly braces, everything inside of the loop is what is occurring. Okay? So if you want multiple things to happen, you need to put curly braces. If there's just one line of code here, this one line of code goes directly with the for. Again, indentation does not matter here. Okay, and you can see my output matched their output somewhat. Theirs is a little bit thinner than mine. For each occurrence of the outer row, the inner column will print 8 stars, and then it's terminated by the new line character. Okay. So, public void picture. What does this do? We have line, stars, spaces, and loops. Okay. So, line. So I'm going to start. Line is 1. Going to keep track up here. Line is 1. And then let's say I have this equal to 4. So n, I'm going to say, is equal to 4. Well, we'll just keep track on the side. You really shouldn't cross over the code. So I'll say n is 4. Okay, and then I have some spaces and stars and then loop. I'm running out of room here in my thing, in my table. Let's see. N line spaces stars loops. That's a little bit better. N is 4. All right. So now line starts at 1. Okay. So inside it says spaces becomes line minus 1. So spaces becomes line, which is 1 minus 1. So this is 0. Okay. For loop starts at 1, while 1 is less than or equal to spaces. So it doesn't even go out in this loop. So it does not even go in here because 1 is not less than or equal to 0. Okay? So it doesn't print anything. Now stars becomes n. So 4 minus 1 plus 1. So star becomes 4 right now. And so now for loop, which starts at 1. So now loop is starting at 1, which I already have at 1, so I'm going to leave it there. Is less than or equal to stars, I'm going to print out a star. So I can see I can print out 4 stars because I'm going to do this until I get to 4. So what happened is loop is 1, and then 1 is less than or equal to 4, and so then it printed out 1 star. And then it said loops plus plus 2. So now loop was 2, less than or equal to 4, it printed out the second star. And then it incremented to 3. And now loop is 3, okay, it's less than or equal to 4, which is still stars, and then it printed out another star. And then this became 4. Well, 4 is less than or equal to 4. Yes, it's going to print out the last star, and then this becomes 5. Once it becomes 5, it pops out of here. So now my cursor is here. All right. And now I go back up to the top and line plus plus. So now I'm here. Line is 2. Okay. And so now this is going to say for loop is 1. So I'm going to erase these guys because now loop is 1. While loop is less than or equal to... Oh, I forgot to do spaces. Spaces is line, which is 2 minus 1. So now spaces is 1. So now loop is starting at 1. While loop is less than or equal to spaces, it's going to print a space. So loop is less than or equal to spaces, so I'm going to print a space. So there's going to be a blank space right here. Okay? And then loop becomes 2. Is 2 less than or equal to space, which is 1? 2 is not less than or equal to space, so I'm going to stop here, and I go over here to stars. So now stars is 4 minus 2 plus 1. So 4 minus 2 is 2 plus 1 is 3. So now stars becomes 3. And loop is starting over again. So loop is at 1 now. So 1 less than or equal to star is 1 less than or equal to 3. Yes. So remember there was a space here. I'm going to print a star. And it increments to 2. Is 2 less than or equal to 3? Yes. I'm going to print another star. Is 3 less than or equal to 3? Yes. Print another star, and now it becomes 4. Is 4 less than or equal to 3? No. So it stops, and there's a print line. Okay? So I'm going to erase all these because loop's going to reset itself. Okay? And I go up to the top now, so line is again 1. So line... Oh, no, line has incremented itself. Sorry. Line has incremented itself to 3. Because at the end of this brace, line increments to 3. Okay, so spaces now becomes 3 minus 1, which is 2. So, loop is 1, resets to 1, while 1 is less than or equal to 2 is going to print a blank space. And then it increments itself. While 2 is less than or equal to 2, it's going to print another blank space right here. Okay? And now it increments itself to 3. While 3 is less than or equal to 2. Oh, wait. 3 is not less than or equal to 2, so I can't go anymore. So I'm halted here. And now stars becomes n, which is 4, minus line 3. 4 minus 3 is 1, plus 1 is 2. Okay. So, now, what happens? I go into my loop again. And this resets. So I can see loop is 1. While 1 is less than or equal to stars. Okay? So while 1 is less than or equal to stars, stars is 2, I'm going to print out a star. And while 2, then this increments itself. Is 2 less than or equal to 2? Yes. Prints itself. Okay? And now it increments to 3. Is 3 less than or equal to 2, which is stars? No. So now there's a print line, and line increments itself. So now line is 4. So is 4 less than or equal to n? Yes. So this is the last time I'm going to go into this loop because 4 is less than or equal to n, which is great because this takes a long time to code through, but it's good to practice. So now, spaces. What does spaces become? Spaces becomes line, which is 4, minus 1, which is 3. So this becomes 3. We can see a pattern that's happening here. So I'm going to print out, well, loop is 1. Okay. So I print, is loop less than or equal to spaces? Yes. So I print out a space. So there's a space here. And then this increments to 2. Is 2 less than or equal to spaces? Yes. So I print another space here. And then this increments to 3. Is 3 less than or equal to spaces? Yes. So I'm going to print a space here. Okay. And then this increments itself to 4. Is 4 less than or equal to spaces, which is 3? No. So now it skips down to stars. Stars is now n, which is 4, minus the line, which is 4. So 4 minus 4 is 0, plus 1 is 1. And loop starts all over again at 1. So is 1 less than or equal to stars, which is now 1? Yes. So it prints itself a star. And then is 2 less than or equal to 1? No. So now it's going to pop out of this loop. It's system.out.println. So now my cursor is here. And I have to remember that line increments at the bottom of this loop to 5. So I try to go in here and compare. Is 5 less than or equal to 4? No. So now I'm completely done with this. So now my method is done. It's printed out this picture. I would go through that a couple times just to kind of be clear. And you can see why I use tables to help me keep track of things. Okay. So the last thing about this is how do I exit a loop? It's really important to know how to exit a loop because I want to be able to get out. So there's 2 ways. If I am, no matter where I am inside of a loop, if I use a break, okay, it's going to exit me out of whatever loop I'm in. So let's say I'm here in this 4, and then there's 2 nested for loops inside. So if I put like curly braces and put a break here, it's just going to continue on to here. If I put a break outside of one of these nested loops, like let's say I put a break here, it would break me out of this outer loop. So it really depends on where you put your loop or where you put your break statement. If you put, it'll break you out of the loop that you're in, but not out of the loops altogether. Now, a return statement, which we use in methods, right? Okay, a return statement is great also if you want to exit right away. So if you're in the middle of a method and you want to exit as soon as you hit something inside of a loop, no matter where you are, inner, outer, wherever you are inside the loop, as soon as you hit that return, your entire exit, you will exit your entire method altogether. So that's really the information about loops. They're fun. I like them. They're a little bit tricky to catch on to, but they help us do things repeatedly over and over and over again, which is something we definitely want. And they also help us get through lists. And that's also something that's super important to us.